Hey, Screech, take a seat. It's time for Networking 101. You know, when you look at Cisco, one of the things you don't think of is really how big we are in OSs, right? I mean, you look at our routers, our switches, our wireless access points, all that stuff. But in the end, what do all those things have in common? Well, they've got an operating system, right? iOS is one of the key components to actually turning that hardware into a very useful device. But really, when we're looking at it, what is Cisco iOS? What is really kind of going on in the background? Well, first off, as a developer myself, we need to apologize, right? We don't make it easy to learn this stuff. I used to joke all the time that the next certification Cisco needs is a CCIE software because, man, understanding our software trains, as we like to call them, is about as difficult as being a trained engineer. Because, you know, you'll see things like this, like 12.17.1b, .7.4.l, on and on and on, right? I mean, you keep seeing all this stuff, and it looks intimidating. It's hard to understand, and it's not simple, you know? And as a developer, we do this stuff to kind of know where our releases are at, right? We need to know that this base code is base 12. We need to know that the mod of this is 17. And we make it easy for us to understand, right? And not simple for a lot of users. So what we did was, as we broke this down, we made this simple, right? You'll see, if you have watched this go, you'll see that we went from version 12 all of a sudden to version 15. What? How does that work? Because there's a few numbers kind of missing here, right? So I went on a investigative journalism report here and tried to find out where those missing numbers went. And so talking to the code jockeys, what they told me is that we didn't do a 13 because of all the folks with triskaidekaphobia, right? Scared of the letter 13. And I had to get that word in because I just learned how to say it from our producer, so I get bonus points. They also said that the letter 14 is unlucky in a few countries, so that actually just left sequentially number 15, and guess what? The next iOS version that comes out with all these cool improvements is iOS version 15. One of the things that we also changed about iOS to really make it a lot easier is that we went away from X and B and L and, you know, E and all these different release codes that we had to say that really that made it developer friendly, and we decided to make it engineer more user friendly. So now when you see anything in iOS version 15, you'll see version 15, you'll see an M or you'll see a T. The M stuff is what we're calling a mainline release, right? That's a big one that we're going to support for, you know, so long for bugs, right? I mean, it's going to have a lot more bugs. I think it's like 44 months or something, but don't quote me on that because, man, you start quoting months and everybody gets mad. But that's a mainline release. T is considered an update to that code, and that's what we're doing. That's it. No more of these silly sub numbers or letters or any of that stuff. This is going to make it a whole lot easier for us to understand how this works on a device. But what is iOS? Now that we understand the versioning, what really is it? What really kind of gives it its meat? Well, iOS itself, when you look at the history, you guys know I always like to toss a little bit of history in there and stuff. But iOS was wrote back in the day, it was wrote on C, like a lot of hardware code. A lot of hardware code is written in C because it's very easy to control how we're shifting blocks back and forth inside of memory, controlling where we're slicing stuff out. And so a lot of stuff is wrote in C, which typically means it's what they'll use the term monolithic. And so which basically means it reads code from top to bottom or bottom to top, depending upon how, you like to look at CPUs, that type of thing. And it served us well for a very, very long time, right? But now as we started advancing, and started doing more things like multi-core, and memory started getting a lot cheaper than what it was, we could go away from this model. See, this is it's not really an easier model, but it's a model that's very memory and CPU friendly, if you will, because it allows us to really run a lot of code and process it very fast, because again, you're just looking at doing something serial. How does Ethernet communications work, right? It works serial. It doesn't work in parallel, it works serial, right? We have full duplex, half duplex, but in the end, those bits are lining up and we're sending them down the straight line. Now, when we started having the ability, started having a lot better hardware, when Moore's Law kicked in and things got a lot better and stuff, knew we need to make a change. And iOS became a lot more modular at that point. And what we really mean here is that anytime you're developing any type of software, no matter what it is, you're basically looking at logical blocks. And these logical blocks can really be separated. There's a lot of ways to do this, but for simplicity's sake, what you're looking at here is block one is what you call the drivers. The drivers are hardware dependent. This depends on what it's going to be on, right? So if it's going to be on an access point, it's going to have drivers that are going to support that access point. Our next piece is actually the code itself. The code itself is really what is telling us that, okay, well, this is a switch and you need to have this range command. This is a router, we need to have these routing commands, so on and so forth. That's what actually tells a switch how to do that. Now, in iOS, one of the things we did, actually a humongous difference between iOS and iOS XE, is that it decouples this driver layer, if you will. Let me go ahead and go to my pin here. It decouples and splits that apart so that now you have your drivers that are away from the central code itself. And this gives us some really big advantages, right? Because now that means that if my drivers are logically separated from this stuff here, that means that now I can update these independently. And so typically if I have a bug in my code here, then I can update this bug without having to reinitialize these drivers. What kills us all, like with different operating systems, is we have to reboot. We do an update. No matter what you have, it's just kind of partial and partial of it, right? We do that because we have to reinitialize the drivers, we have to reinitialize the hardware, because you can always tell what bug was fixed. Is it a bug in the drivers? You have to reboot the machine. If it's a bug in the code, typically you don't. So an insert joke here for which operating system that's true and false on. But that's a real big difference that we went with iOS XE, XR, all that type of stuff, is that whole decoupling fashion to make this work. And that's really what makes it kind of stand out. Now, real quickly, you've also known, if you've been at Cisco or heard some of the old school guys talk about, you had iOS, and then, boy, that is just really ugly color. You had iOS, and then you had Cat OS. Any switch goobers out there remember the Cat OS days. And Cisco is kind of a victim of a lot of the acquisitions we've done. iOS was designed for routers, right? I mean, it was designed for routers. And how many interfaces do you have on a router back in the 80s when this stuff was designed? 1, 2, maybe 3 if you're lucky, because they were pretty pricey. And why in the world would anybody need more than that, right? So Cat OS was part of some acquisitions, and it had what we needed. It had range commands, right? It allowed me to make it act like a switch, so I could say, put ports 1 through 24 in, I'm running out of space here, ports 1 through 24 in VLAN ID 12. And that's the kind of stuff we need to do on a switch, right? We need to support a bunch of bridge ports, a bunch of ports out there to make this stuff kind of happen. And then as time moved on, we actually shifted over and we went to what some people call native mode. So you remember iOS native, some people call it iOS N, and it was just a way to kind of emulate iOS on top of this stuff. Now we've really tried to consolidate that, thank goodness, right? We're running iOS all over the place. And typically what you have now is that you have iOS, and then you have the sub parts of that, XR, and XE, which have very different needs. You have Nexus. Nexus is data center code. And that code is designed very specifically for incredibly high availability. I mean, even the drivers inside the drivers are modularized, so you can do a lot more very data center specific functions on there. And because they're bigger switches, they got a lot more horsepower, we can do a lot more with that. Versus, standard iOS that may be in, like a 3750 or a 6500 and stuff. What we're doing there is, although you have a lot of power and stuff, there's no reason to overcharge people. We're going to optimize this based upon the hardware to take the best part of the stuff out there. So we've tried to really make this a lot easier, and thank goodness, boy, it isn't like it used to be, to really make it easier when you're designing, when you're updating your firmware, and actually as you're building your networks out and you're trying to service this stuff. It's so much simpler than what it was. Nexus is for data center. iOS is for pretty much just about everything else. We run it across the board on everything, and it works great. It's very reliable. It's incredibly resilient, and the fact that we've went to this whole decoupling model really makes it an attractive option for today's type of data processing.